Usually when we talk about like a massive technological breakthrough, there's this expectation of an immediate sweeping transformation, you know?
Absolutely, like flipping a switch.
Exactly. You look back at the invention of electricity, you flip a switch, the lights come on, and literally every factory in the world changes how it operates overnight. But you step into the current state of industrial artificial intelligence, and that light switch is fundamentally broken.
Yeah, it's really a landscape defined by this staggering contradiction right now.
It is. I mean, AI is processing massive amounts of complex industrial data at unprecedented speeds, yet corporate adoption of this technology is totally stalled out. We're generating brilliant answers faster than ever, but the real-world application is just, well, it's stuck in the mud.
Completely stuck.
So, welcome to the deep dive. Looking across our stack of materials today, we've got some fascinating stuff. We're looking at a recent press release from EON AI Ventures dated August 25, 2026, along with their white paper, From Data to Decisions.
Right, and we're pairing that with a really sharp quartz analysis by Sheridan Hansen, plus some fairly sobering survey data from McKinsey and EY from 2025 and 2026.
Yeah, it's a great stack. And our mission today is very specific. We are going to figure out why this tech revolution hit a brick wall and how the ultimate solution has like absolutely nothing to do with building better computers.
Which is wild to think about.
Right. It turns out the fix is entirely about human competency. And it might just end up replacing the traditional 20-year industry veteran with a 2-year novice inside a digital twin. So, okay, let's unpack this, starting with the sheer scale of what the computational side of AI is actually getting right.
Well, the raw processing power is largely a solved equation at this point, and we can actually quantify that leap. If you look at the 2025 data, BP provides us a textbook example of this computational victory.
Oh, the Gulf of Mexico project, right.
Yeah, exactly. They were dealing with seismic data processing in the Gulf. And mapping the ocean floor to figure out where to drill involves just an overwhelming amount of geological data. I mean, historically, feeding that data through traditional models took BP a sluggish 6 to 12 months just to process the findings.
6 to 12 months of just waiting around.
Right. But by integrating AI into that specific workflow, they compressed that entire timeline down to an incredible 8 to 12 weeks.
Wow. I mean, going from a year of waiting to just a couple of months, that fundamentally rewrites the financial calculus of an energy project.
Oh, absolutely. The numbers are staggering.
Because, the capital expenditure in offshore drilling is astronomical. So
Yeah.
shaving 9 months off your discovery phase, that saves tens of millions of dollars before you ever put a drill bit in the ground.
It's a massive win.
Yeah, and you see a quantifiable win like that, and you assume every major player in the heavy industry sector is completely overhauling their operations to capture that efficiency.
Well, the expectation is certainly there. I mean, the 2026 McKinsey survey of oilfield services and equipment executives captures that sentiment perfectly. Over 75% of those executives fully expect generative AI to deliver massive operational efficiencies.
Which makes sense. They see the BP use case, they understand the math.
Right, they want those margins for their own operations. But the contradiction reveals itself when you look at the actual deployment. That same survey indicates fewer than 25% of those companies have actually moved past the pilot stage.
Wait, less than 25%. So they just run a test and then, what, give up?
They are trapped in what the industry calls pilot purgatory. They run a small, controlled test that works beautifully, but they just cannot figure out how to scale it across their global workforce.
Oh, wow.
Yeah, and the survey explicitly notes this aligns with a broader McKinsey finding across all industries, showing roughly 2/3 of all organizations haven't been able to scale AI enterprise-wide.
It's like we've built the world's most advanced GPS system, but we forgot to install a steering wheel in the car.
That is a perfect way to look at it.
I mean, the AI knows exactly where the oil is, it knows the optimal pressure to extract it, and it gives us the coordinates in record time. But the human workforce has no physical mechanism to steer the massive, complex machinery based on those new rapid-fire coordinates.
Exactly. What's fascinating here is that speed without human execution is entirely useless in high-stakes environments. Getting a geological report in 8 weeks instead of 12 months yields literally zero financial return if the engineers receiving that report lack the operational capacity to act on it safely.
We have a pristine data output, but the interface between that data and the physical world is just broken.
Yeah, and this dynamic is the core of Sheridan Hansen's analysis in Quartz. Hansen asks a defining question about the current state of the industry. Can AI actually extend human engineering capacity?
Because generating a faster geological insight doesn't automatically construct the pipeline, right? It doesn't manage the pressure valves.
No, it doesn't. In heavy industries like oil and gas or chemical manufacturing, fast insight is meaningless if the human operators on the ground cannot execute the subsequent complex high-risk procedures. They have to perform these tasks safely on the first try.
Right, you can't just guess and check with a gas pipeline.
Exactly. You cannot iterate your way through a dangerous industrial procedure the way you iterate software code. I mean, a bad line of code causes a glitch on a screen. A wrong turn of a valve on a high-pressure line causes a catastrophic environmental disaster or a loss of human life.
The stakes are just infinitely higher.
They really are. So the gap between the machine's processing speed and the human's execution capability, that is the primary bottleneck stalling AI adoption right now.
And that bottleneck brings us to arguably the most alarming data point in our entire stack of sources. EY ran their Future of Energy survey in 2025, focusing on oil, gas, and chemicals executives.
Yeah, that survey was a huge wake-up call.
Definitely. They uncovered a massive structural gap in how these companies are preparing for the future. I mean, 85% of those executives stated clearly that their ability to reskill their workforce will entirely determine their success over the next 5 years.
So they know exactly what the problem is.
Right. They are universally aware that human competency is the make-or-break issue for their survival. Yet, an abysmal 29% of them are actually retraining their people today.
That gap between 85% awareness and 29% action represents a systemic failure in workforce development.
But wait, 29% isn't just a structural training problem, is it? I mean, if executives know this is a life or death issue for their company's survival and they still aren't spending the money to retrain people, it sounds like they are just protecting this quarter's margins.
Well, there's always a financial angle, sure.
Like, they are keeping operating costs artificially low to boost short-term profits instead of investing in long-term safety and competency. Are we letting corporate leadership off the hook by blaming the technology for this massive shortfall in reskilling?
I see your point. Protecting short-term margins is definitely a factor in corporate decision-making. But the root cause of that 29% figure is actually the sheer physical limitation of industrial environments.
What do you mean by physical limitation?
It is incredibly difficult, astronomically expensive, and deeply dangerous to train inexperienced personnel on live assets. If you are operating a multi-million-dollar refinery, you cannot just shut down a catalytic cracking unit for an afternoon just so a new hire can practice a shutdown sequence.
Oh, I see. Because the downtime itself costs millions.
Exactly. And a single mistake by that trainee puts the entire facility at risk. The traditional method for navigating this limitation is having new hires shadow senior workers.
Like an apprenticeship model.
Right. But that apprenticeship model is incredibly slow. It pulls your most productive veterans away from their actual jobs, and it simply doesn't scale fast enough to keep pace with how quickly AI is altering the operational landscape.
So they literally just can't train people fast enough.
Yeah. Dan Lajerskar, the founder and chairman of EON AI Ventures, captures this bottleneck perfectly. He stated, "The industry has spent its AI budget teaching machines to read data faster. The unsolved half of the problem is teaching people to act on it."
Teaching people to act on the data is the missing link. We have built incredibly smart oracles that hand us brilliant, mathematically perfect answers, but we haven't built the mechanism to upgrade the human being who actually has to carry that answer into the physical world and turn a wrench.
That's spot on. Lajerskar points out that processing speed without human capability is just a report that nobody can execute.
Just another PDF sitting in an inbox.
Exactly. We are generating terabytes of actionable intelligence, but we are feeding it to a workforce constrained by analog training methods. Reading a PDF manual in a classroom does not build the muscle memory required to operate a deep-water rig during a pressure anomaly.
And that physical constraint sets up exactly how EON AI Ventures is attacking this gap. Looking at their white paper and recent press releases, they aren't trying to build another large language model that simply analyzes seismic data faster.
No, they're taking a completely different approach.
Right. They've built something called the Genesis platform, which functions as the core of their broader intelligence flywheel, a system that also includes these field modules called Field IQ and Assess IQ. And their architectural approach is so interesting because it focuses on the data companies already own.
Yeah, they target a company's existing engineering data.
We are talking about standard operating procedures, CAD files, and incredibly dense P&IDs. They ingest all of that stagnant documentation into the Genesis platform to essentially solve that training bottleneck we were just talking about.
Taking that static knowledge and giving it a dynamic spatial environment requires a very specific integration of different AI models. To understand how they actually bridge the gap from a flat PDF to a physical simulation, you really have to look at the dual stream architecture of the platform.
Okay, so how does that dual stream thing actually work?
First, they use large language models to ingest the standard operating procedures. The LLM parses the sequential textual logic, for example. Step 1 is closing valve A. Step 2 is monitoring pressure gauge B until it hits a specific threshold.
So the LLM reads the instructions. Got it.
Right. And simultaneously, their computer vision algorithms ingest the CAD files and the piping and instrumentation diagrams. The vision model maps out the spatial geometry of the facility.
Oh, so it builds the physical space.
Exactly. It understands exactly where valve A is located in three-dimensional space relative to gauge B. The Genesis platform then fuses these two models together. It overlays the procedural logic extracted from the text directly onto the spatial geometry extracted from the CAD files.
That is wild. The AI is essentially auto-generating a physics-bound environment where the text instructions are mapped directly onto the digital object.
Yeah, it builds the simulation without requiring an army of human software developers to manually code the physics of every single pipe and valve.
Okay, but let me push back on the end result of that creation process for a second.
Sure.
Ingesting CAD files to build a 3D environment just sounds like a fancy VR video game. I mean, we've seen corporate virtual reality headsets for the last 10 years, right?
Oh, definitely.
They usually get used once at a safety seminar and then sit in a closet gathering dust because they don't actually move the needle on heavy industrial productivity. Is this genuinely different from those previous immersive training fads, or is it just like a slicker version of a VR walkthrough?
That is exactly why EON explicitly distances themselves from the VR and AR labels in their white paper. They position themselves as an AI-first workforce capability platform.
Okay, so what's the actual difference, though?
The visual simulation is merely the interface. The core technology is the verifiable assessment layer running underneath it. They're not generating these photoreal simulations for basic familiarization or entertainment. They're generating them for auditable proof.
Auditable proof, like for safety compliance.
Right. Exactly. In HSE critical work involving health, safety, and environment protocols, you need objective data. You cannot have a worker take a multiple-choice test and assume they can handle a high-pressure blowout.
Right. Checking a box on a quiz doesn't mean you won't panic when an alarm goes off.
Exactly. So EON's platform tracks every micro-action the worker takes inside the simulation.
Ah.
It verifies they followed the exact safety protocols in the correct sequence under simulated pressure, and it actually generates a cryptographic digital receipt of their competence.
Oh, wow. So it replaces a passive training record with a verifiable guarantee of readiness.
Yes, that's exactly what it does.
I mean, a sign-in sheet at a morning safety briefing simply proves a worker was in the room while someone talked about a procedure. Auditable proof dictates that the worker actually performed the procedure flawlessly in a zero-risk digital twin of the specific facility they're about to step into.
Right. And if regulators or insurance companies come knocking after an incident, the company has hard data proving the individual demonstrated physical competency before they ever touch the live asset.
That is a massive liability shield.
It is. And that verifiable assessment layer is what allows companies to finally scale their workforce training without risking their physical infrastructure. The sources point out that EON is currently deployed at operational scale in over 80 countries.
80 countries, that's huge.
Yeah. Going back to that McKinsey data where fewer than 25% of firms had moved AI past the pilot stage, EON is bypassing pilot purgatory entirely because they're solving the human element of execution rather than just optimizing the data analysis.
That makes perfect sense.
Mats W. Johansson, the president of EON AI Ventures, summarizes their value proposition really well. He says, every operator we work with is sitting on decades of procedural knowledge locked inside documents. We make that knowledge executable.
So what does this all mean for you, the listener? If you're listening to this right now, you likely don't work on a deep water oil rig, and you probably don't spend your days reading complex piping diagrams.
Probably not.
But you absolutely recognize the underlying problem here. Think about your own workplace. Think about the sheer frustration of knowing your company possesses decades of procedural knowledge and institutional wisdom, but it is entirely locked inside incredibly dry documents, endless PDFs, and outdated training manuals buried on a shared drive somewhere.
Oh, everyone has experienced that. The knowledge exists within the organization, but it is completely inert. It just sits in a database waiting for a human being to decode it, interpret it, and figure out how to apply it to a real-world scenario.
Right. It sits there waiting for one of your company's few scarce expert trainers to finally find a free hour on their calendar to pull you aside and explain how the process actually works in practice. It is a universal bottleneck.
It really is. And EON N frames this broader philosophy around a concept they call work intelligence. It is the deliberate pivot away from the traditional framing of artificial intelligence.
Work intelligence, I like that.
Yeah, they define it as the captured, verified, and compounding knowledge of how expert work is actually executed in the physical world. If we connect this to the bigger picture, the true enduring value of AI isn't simply its ability to generate more information.
Because we are already drowning in information.
Exactly. The true value of AI will be its ability to expand how much of that information a human workforce can meaningfully and safely act upon. The goal is closing the massive gap between what a corporate entity theoretically knows and what that entity's employees can actually do on a Tuesday morning.
We started this deep dive looking at a landscape defined by contradiction. AI delivered world-changing data processing speeds, but it stranded major industries with a reskilling gap they had absolutely no physical way to cross.
Until now.
Right. Platforms like EON's Genesis represent the architectural bridge over that gap. They are turning stagnant, locked-away text documents into verifiable, executable human competency through spatial AI.
They are essentially translating the speed of the machine into the physical capability of the worker.
And here's where it gets really interesting. Because if this technology scales across all heavy industries the way the sources suggest, it fundamentally disrupts a concept we have taken for granted since the dawn of the Industrial Revolution.
It really forces us to question the nature and value of expertise itself. I mean, if an AI platform can flawlessly extract the most complex expert procedures from dense manuals, encode them into hyper-realistic simulations, and objectively verify a worker's competency before they ever step into the field, what happens to the traditional value of on-the-job experience?
That is such a fascinating question.
Right. We have always placed a massive premium on the 20-year industry veteran. We trust them because they've seen it all, they've made the mistakes, they have learned from the edge cases, and they possess decades of tacit knowledge that just isn't written down anywhere. Exactly. That novice has built literal muscle memory for catastrophic scenarios the 20-year veteran might have only encountered once in their entire career.
Wow.
If simulations can compress decades of experiential learning into a few weeks of verifiable, auditable practice, does the premium we place on the traditional veteran begin to disappear?
Does simulated experience eventually outrank physical tenure? I mean, if the system can generate cryptographic proof that you know exactly how to execute a flawless procedure under pressure, does the industry still care how many calendar years you've been on the payroll?
It's a total paradigm shift.
It really is. We are going to leave you with that one to mull over.
Yeah.
Thank you so much for joining us on this deep dive. Keep questioning the world around you, keep looking for those hidden bottlenecks, and we'll see you next time.